The Gain-Polarity-Delay tab is used to set alignment, delay and gain that will be used in the target processor. It's particularly useful for driver alignment in a multi-way system. This demo uses FIR Designer M, which is built for multi-way DSP design. The top plot shows the impulse response, or time plot of the measurement before and after gain, polarity, and delay adjustments. For this two-way example system design, we first need to load both impulse response and driver measurements into the Import tab. All uploaded data needs to have the same time reference. On the Import tab, we apply the same gain offsets and delays to both the high-frequency and low-frequency channels to ensure that the relative acoustic time difference between the drivers is maintained during the DSP design process. We've time-aligned to the high-frequency driver impulse response peak, as this makes phase adjustments and response comparisons much easier throughout the design workflow. On the FIR tab, you can see the crossover filters at approximately 1.3 kHz. The goal is to match level and phase between the channels around this frequency with the crossovers applied. The crossovers could be symmetric or asymmetric, and FIR or FIR, or a mix of both. Alignment decisions should consider overall dispersion and off-axis measurements. Dispersion can be analyzed using the built-in supplementary response function, but that's beyond the scope of this video. Back on the GPD tab, we'll drop the gain of the high-frequency driver to better match the low and high-frequency response levels. By viewing the FIR tab in a second view window, we can see the FIR filtered responses without leaving the GPD tab. It shows us that the combined FIR response is reasonable, but the phase and phase slope don't match well in the crossover region. One option to improve the match is to simply delay the low-frequency driver until the phase slope matches. This works quite well, and we could stop here. Note that the combined phase has two full rotations 720 degrees through the crossover region. An alternative is to invert the high-frequency driver, then adjust the low-frequency delay to match the high-frequency phase slope. This results in a similar combined magnitude response, but with less overall phase rotation and therefore less effective delay between the low and high drivers in the combined response. Now the drivers are aligned, we're done using the Gain-Polarity-Delay tab in FIR Designer M, and can proceed through the other workflow tabs to complete the DSP system design. Users of the single-channel FIR Designer also have access to a Gain-Polarity-Delay tab in the workflow, which is helpful if building a multi-way system from several separate single-channel projects. Since the combined response across all channels isn't available in FIR Designer, it should be confirmed with additional measurements following implementation in the processor. That's it for the Gain-Polarity-Delay tab.